Thank you for coming to our session. It's the overview of the SaltStack core components. This session is kind of interesting to be tasked with this session because many of you have experience with Salt, yet the core components sometimes tends to, on the surface, be basic. So hopefully we're going to be able to provide some insight to some of the components that you use day in and day out with Salt, and then also provide possibly some new ways to think about how to use some of these components. Also, please feel free to ask questions. Sometimes in these things we tend to just kind of ramble and start to go on, but if you have a question, please feel free to ask. And the only thing I ask is you're not mic'd, so speak up so that we can understand those questions. As a matter of introduction, my name is Mark Hopper. I'm a technical solutions consultant for SaltStack. How many of you were at SaltConf last year? I wasn't. There's a few of you. How many? So, just a show of hands, just for effect, right? How many is this your first time at SaltConf? All right. So, if you were here last year, you don't recognize me. I'm fairly new to the company, like the vast majority of us at SaltStack. But we're excited to be doing this presentation. I'll let my partner in crime here introduce herself.
Okay, yeah. Hi, everybody. I'm Nicole Thomas. I'm a QA engineer here at SaltStack. I've been here for a little bit longer than a year, so I was at the last SaltConf. I recognize a couple faces, but most of you are pretty new. So, new to me anyway. So I just kind of wanted to show you guys what we'll be covering. The goal that we had for this presentation was kind of to talk about some of the other things that Salt contains, with the goal in mind that maybe a lot of you are new to Salt, or maybe you've been using it for a while, but you've only been using execution modules and states, and then you're like, well, I've heard of returners, but I don't really know what they do. So we wanted to kind of give an overview of how all of these pieces sort of fit within the Salt ecosystem. So we'll be going over, on a basic level, these different things. And there's a lot of pieces, so feel free to ask questions like Mark said.
So the first piece we're going to talk about is execution modules, and this is kind of where everybody lives in Salt, ultimately. At our core, Salt is an orchestration engine built on remote execution. And so the execution modules are kind of the core of that. And so you're going to be using, the format is the command, in this case, Salt. You're going to target something. In this case, we're targeting everything, but you could target a grain or whatever. From that perspective, machine. And then I like to term this as kind of a noun verb. We have the module, in this case, disk. That's the module. And within that module, so that's kind of the noun, we have the object disk. And then the function, and there'll be multiple functions based on the execution module of usage, and that's kind of verb. So I kind of use this noun, verb. I spend a lot of time talking with people who are not technical, and so I kind of use terminology that outside of the words module and function. Sometimes C-level people kind of get that, kind of makes them a little bit nervous sometimes. So I try to do an analogy, and then obviously after that there may be parameters that we put on there. And so the execution modules are sent, the commands sent from the master to the minion, and then the minion actually executes those modules. That's your basic function, and things like salt call and some of those other things, salt SSH and some of those other things out of scope for this course, but there are plenty of other sessions that will talk more in depth. For example, salt SSH and some of those other things that if you are interested in how does the execution module work in some of these other out-of-the-box use cases, there's plenty of sessions. So, and then the execution modules just kind of build upon on states. The other thing I want to point out is this execution module usage is independent of the operating system. So if you're using, a Debian version of Linux versus a Red Hat flavor of Linux, or you're using Windows or Solaris, Unix, FreeBSD, if the module supports those operating systems, the syntax is the same. So it simplifies your administration. You don't need to remember, do I use Yum or do I use app repository, or what in the world is this Windows install? I don't normally do Windows. So those kind of things is another piece of the execution module.
Okay, I'm going to talk about states really quickly next. So similarly to what Mark was saying about how the command is constructed, we're doing the same thing. We're calling salt. We're targeting all our minions with the star. And then we're going to use the state module to call an SLS file. So the SLS file lives on the master, and then it's named Redis, right? So Redis SLS at the top. And then this state file just kind of is, it's a way to enforce state on your minions, right? And these can be super simple, like this example that we're showing here, where we're just installing the Redis server package, and then we're ensuring that the service is running. Or it can be very, very complicated, and they have all kinds of different requisites and ways that you can tie them together to enforce all kinds of things on your minions. So, but basically what's happening is very similar to the command the execution module, where we're executing the state. The state goes out to all the minions. The minions are they're the ones that are doing the matching, so they say, oh, this goes to everybody. I'm one of your minions. I'm going to execute the state. Then they ask the master, then they say to the master, hey, send down this state so I can run it. They run the state, and then they return the results to the master. So that's kind of how that works. And changes on the state aren't made unless needed, and you can kind of order how you want to execute your states, both in a declarative fashion and in an imperative fashion. So I know if you guys are new, this is kind of a lot, and if you've used states before, you're like, oh yeah, we know states. So that's just a brief overview. There's lots of other talks you can go to learn more about that. So we're going to keep going.
So,
well, do you guys have any questions so far? Kind of flying through those a little bit quickly. Mm-hmm. Correct. I think so. Yeah, so in case you guys couldn't hear, his question was kind of about the direction of the way that the command is going. So the master sends the commands in a broadcast signal, and then it's up to the minions to match against that signal. So there's a lot of different ways you can target minions. Right here is a very simple example to target all of your minions. And so the minion is saying, oh, yep, I'm one of your minions. And then it goes back to the master. And then the master said, so the minion requests the state because it matched, right? And if the minion already had that state, it would be cached, so it would just use the cached version. But if it's not cached, it asks the master, and then the master sends it back down. Does that answer your question? Mm-hmm. Yep. I think that sounds right. Yeah. Yeah.
So I think the point she's making, I think, is correct, and I just preface, I reserve the right to be wrong. So I always reserve the right to be wrong. I fail a lot, and I try to fail fast, and that's how I deal with life. But I believe what's in the communication, I believe you only need the ports open on the server, because what happens is we are using 0MQ for the message bus, and that bus is a persistent connection. So the ports on the firewall, on the minion, can be locked down. It's the two ports, there's 4505, 4506 or something. I don't know what those, I don't pretend to memorize those numbers,
right.
But they're open on the master. And then all the traffic between the minion and the master happens across that 0MQ bus. Right. So just if you couldn't hear that, because I could barely hear it, the outbound ports need to be open on the minion, but the inbound ports can be locked down, whereas the server does need to have the inbound ports. So.
Any other questions?
Any other questions on this? Yes, it is. Ultimately is a push configuration, because the master is sending that instruction set across that message bus, and then the minions determine based on the targeting, in this case everybody, and then the minion will pull down the SLS file from, so it is a push, in that sense it's a push configuration.
Yeah. Mm-hmm. Right, so the answer to that question is using SaltCall. Yeah. Mm-hmm.
SaltCall.
Salt-call. Yeah.
The data structure,
Yes,
because
correct.
ultimately in the state file is a list of is referencing the data structure references the modules, and those modules have been synced to the minion. That's correct. Yeah. So.
Right. Exactly.
So.
Yes. Thanks for clarifying that. Definitely.
So then and then obviously we're not going to talk about it, but you can also actually, for those that don't know, apply multiple states across the entire infrastructure. We call that putting things into a high state. That's a little bit out of the scope of this particular session, but you can have the multiple states applied all in an organization. So the next thing we're going to talk about is grain data. And so I'm fairly new to Salt, and one of the things I really love about Salt is the wordplay that we have with the product, and so I really love the idea of grains. Salt grains are data points or data values that exist about the minion, and the key thing is they exist on the minion. And typically, we do collect a series of grain data automatically. When the minion starts, it goes out and gathers this dynamic data, what I call dynamic data. You could probably have a philosophical discussion around that. But in that data, we're going to capture things like OS family, OS type, OS version. We capture Python version, 0MQ, IP address, memory, CPU type, all sorts of information that we gather dynamically on the minion. And that data can then be used to do various things. And that data can be used mainly, one of the big things to use that data for is to target. So I can target all my machines with a particular value of grain data. So for example, if I needed to upgrade the version of Python, probably don't want to do that just out of the box, but if for some reason I had the need to update the version of Python, I could actually issue a command and only target the machines with the particular version of Python. Now, that's just an example. The other thing about grain data is while we do gather a set of, out of the box set of grains, you can create your own grains, and you can create whatever data type, it's a data type, and you can name that, label that as what you want, and put the value as what you want. So when I'm demoing to customers, I have grain data of role, and then I assign that role web server, for example. And then I can target all my web servers or all my app servers. And so grain data is something really good to use for targeting, to grouping machines together and then targeting those groups. The key factor here is that grain data resides on the minion about that particular minion, and that data could be accessed by other people. It's not really secured. You don't want to put secure data in a grain. You don't want to be storing passwords in a grain, for example. So that's kind of the grain, salt grain data. If we go to the next one, we have basically, there's kind of 3 data groupings that I'm going to be talking about. The next one is pillar data. And pillar data is very similar to grain data. They're kind of related. And again, I love the wordplay of this. You know, you take a bunch of grains and you stack them on top of each other, and what do you get? You get a pillar of salt, right? So I love that. But there is some fundamental differences between pillar data and grain data. The fundamental difference to me is that pillar data resides on the master, is only accessible by the master, so therefore is, because the communication between the master and the minion is secure, the master controls that data, and so that is a place where you can store secure data like passwords. So I was talking to somebody yesterday, and they were talking about where they have these configuration files that they push out to their environment, but there are certain config files they couldn't push out because those config files had passwords in them. So then somebody had to, instead of pushing out a known, they had to have a mechanism to replicate these config files without the password, and it was a challenge. So that is one use case where you could store, for example, if you had password to a MariaDB, for example, and you wanted to deploy a MariaDB, but you wanted the password to be the same, or for your DB admin, or maybe different, you can store that password in pillar data, and when you apply the state file that Nicole talked about to build that MariaDB, you can then call the pillar data and send that down to the minion. The other key factor is the pillar data is never stored on disk of the minion. So it does get sent to the minion when it's called upon, but it is secure that way. And you can do minion-specific data in the pillar as well. So that's kind of another data set. So there are some similarities. You can store, I've heard some people storing things like roles of computers within pillar that you could store on grain data, but the key factor is the secure nature.
So the pillar data isn't put into the minion's logs anywhere?
No. It's stored now. If you're calling pillar data, the job cache will track that you're calling pillar data, but we're not going to store that data on the minion at all. That's, that kind of, again, the pillar provides that secure, and you can actually put that into a secure file system on the box so that you have security from around that standpoint.
Yeah, you can.
She's got that. It's not on. Yes, you can target on. The question was, can you target on pillar data? The answer is yes.
Yeah.
I don't know if there's a theoretical limit on the amount of grains you can have on a system. I have not heard of that. That doesn't. I see people some of our developers like shrugging. I don't know of any limitation. There's not a known limitation on how many grains you can have. Yeah, we'd have to talk to someone a lot smarter than me to find out if there's the theoretical limit on the number of grains. Right. So then the next piece of information, and this is where we're kind of opening up a can of worms a little bit. I've got Pandora's box, and I'm just about to open it up. And I'll be honest, I don't know what's completely in Pandora's box. So I know that there is Mike Place in the back. I believe he has a session where they're going to talk, at least this rumor that I heard, there's a session where they're going to talk more in depth on these kind of topics. And he's in the back. He's being the rebel and wearing the black shirt instead of the white shirt. So he'll stand out as a Salt employee because he's running his own show, which is great. I love that. But so we have this concept of a mine, a salt mine, and this is data, again, resides on the master, but it's a place to store data about minions for other minions, and that you can leverage that data. And let me kind of give you an example that I use on a daily basis as a solutions consultant in the sales process. I give demos. That's basically what I do. I'm kind of a demo monkey. But in my demo environment, I have a reverse proxy server that I use kind of as a pseudo load balancer, and I have 2 application servers. And I build these servers dynamically for my customers. I spin them up in a cloud environment dynamically, and then I talk about Salt Cloud and the things of that. That's kind of the flow. But in that process, what I do is I gather grain data, the IP address of the web servers, and I store them in the mine as part of the build out process. So I spin something in a cloud. I don't know the IP address because AWS, Azure, whoever I'm using dynamically assigns that. I put that in the salt mine, and then I use that later. And then as part of the build out process of my state file, we actually configure that reverse proxy to listen for and publish the information coming from those web servers. And so those IP addresses are used to configure the reverse proxy with the dynamic IP addresses. And so the reverse proxy server is gathering that information, so that minion is getting information from the mine about its web servers that are sitting behind it. So that's one use case for the salt mine to use data about minions and leverage. And so that's so it's another set of data, similar pillar grains. However, it's on the master, and it's used for other minions to get information, to store information from minions for other minions to leverage somewhere else in a process. That's what I use it for. More like grains in terms of security. No, I have to tell it. So I in my file, I tell it to go to the mine, and then I leverage. Okay, go in the mine, and I use network.ip adders to pull the data. But I have to tell it to put it in the mine. It doesn't automatically do that. Question. In my case, the minion is gathering that data as part of the build-out process. It's part of the state file, and it stores it in the mine. But we'd have to talk, again, someone smarter than me to understand the data flow there. Like I said, I'm just openly opening Pandora's box here. So. I believe that's stored in a file. Is that correct? I'm getting some nodding from the back. So, from the Genius Bar, the real Genius Bar sitting back there. So, yeah. So it's stored in a file, similar to, pillar. Ultimately, grain data stored that way as well. So, okay. Question over here. So in my case, it's the IP address, right? So it could be any kind of grain data. There's probably other data that can be stored there. In my use case, I'm gathering the IP address grain data, and I'm putting that in the mine so that my load balancer can configure itself to. Yeah, it's asking for those particular sets of data.
I think what she's asking is there a way to say that only the load balancer can get the IP addresses of
I believe all minions have access to the mine. But again, the minion needs to be told to go gather that. So again, it's not a place for secure data that I know of. But all right.
Okay, so I'm going to talk about the reactor next. And I know we're going over a lot of stuff really quickly. The reactor is really cool. So the Salt has an internal event system that it's really integral to how everything works in Salt. And so when things happen, an event is sent to the event bus, whether that's an internal event or whether it's something that's coming from the minions, and it comes into the event bus, and then the event bus broadcasts that out and says, this is what happened. So the events themselves, so the event bus it's an open system, and it's used to notify either SALT or other systems that the operations have happened. And each event is just a dictionary that contains info about that event. One of the things that's contained in that dictionary is a tag that we can use for top-level layer filtering, so it's really fast. So what we can do with a reactor is we can configure a reactor to listen to a particular tag. And when that tag comes in, we can do things with it. So, you want to, an event happens and you want to respond to it, is basically what we do with the reactor. So a simple example would be, say when a minion starts and connects to the master and it starts up, you want to clean all of the files out of your temp directory every time that the minion starts. So you can set up a reactor so that when that event comes in, the reactor is listening and says, oh, this minion has started, I have that tag, now I'm going to go send the command to that minion to clean out its temp directory. And these are defined similarly to state files. It's just YAML, right, to send that dictionary data down. Something else you could do, again, when the minion starts, in a simple example, is you could sync your custom grains down. So if you've defined custom grains on your master and you want to sync that grain data down to your minions, when the minion starts up, you can create a reactor so that you don't have to remember to do that every time. It'll just send that for you. A more complicated example that I've used a little bit before is we have an EC2 cloud reactor. So if you're ever using Salt Cloud, and you guys know that with EC2 you can use, what is it called? Their auto-scaling stuff. So if you're using EC2 and they have a new VM comes up, well, your Salt master doesn't necessarily know that a VM has come up. So what you can do with the EC2 reactor is to say, when AWS spins up that new VM, it can notify your master to say, I have this new VM. And the reactor will say, okay, great. We don't need to go through the regular Salt Cloud process of creating the VM and doing those things, but then we can take it from here. Now that this VM is here, now let's pick up where we left off. Salt that minion, do any kind of setup that we need to do, and then we can go on from there to utilize that auto-scaling functionality. And this is just an example. There's many, many things that you can do with the reactors. That's a little bit more of a complicated one. But and then if AWS says, oh, we don't need this VM anymore, and they delete it, we also want to clean up those keys, right? So that's what the EC2 auto-scaling reactor can do, is to clean up those keys after that VM doesn't exist on your cloud anymore. Just an example. Sorry. Oh, okay, sorry. We're running out of time, so I need to talk a little faster. But anyway, it integrates with the mine. It integrates with runners and returners, which we'll talk about here in a minute. And then if you want to learn more about the reactor, Colton in the back is giving actually 2 talks about this very thing. You're not? Oh, never mind. I thought you were talking with Dave about...
Dave is doing it, but I'm not on that one.
Oh, sorry. You're right. He's on that one. Apologies for that. That's a different one that you're doing. Yeah, so if you're interested in learning more about this in depth, I'd go see Dave Boucher's talk on the reactor.
There's two of those sessions, one today, this afternoon, one tomorrow afternoon at 2:40, 2:30, something.
Okay, here's another one that we'll just cover briefly, but a returner. So a returner is basically, in a normal master minion setup, when you send commands or states down to the minion does the work and it returns it back to the master, just returns it back to the master. But say you wanted to have some kind of, you can do anything with this data, right? So we could set up what's called a returner so that you can store that return either in a database or something like syslog or something to kind of help either archive that data or use it, for scalability purposes.
Does that replace the returner talking to the master, or is it additional to?
I think it's additional. It's additional. Yeah, so there's a couple ways you can define using a returner. You can use it on the command line just like this says right here. You just say -- return. And you specify the returner you want to use, or you can use it as a minion or master configuration. You can either have the minion send its returns to your external database, or you can have new in 2014.7 releases, you can also have the master return that. So the reason you might want to do one or the other is if you have a database, you don't want all 200 or 2,000 minions connecting to the same database. You can all send that to the master, and then the master would export that to the database, right? Whereas something like syslog, you might want to be on the minion because it's more how it works. Yeah. Some of the uses. So if you wanted to have any kind of archive of what kind of returns you're getting so you can analyze it later, would be one of those, something that you can do on a longer term basis than, I think, the job cache, for the master, it refreshes every 24 hours. So if you want to keep something like that longer, if you wanted to send things, if you had a lot of minions and you wanted to kind of have all of that return data exported somewhere else, so it's not just coming through on your master and slowing you down, that would be another use case.
Possibly for reporting, long-term historical reporting of jobs or security audits. There are various reasons why you may want that bus traffic to be sent over to them.
Yes. Oh, yeah, there's tons of returners. So I'm trying to think, there's a list. There's about 25 to 30 different returners that are built in and come with Salt. I can't remember what any of them off the top of my head. Yep, so if you go to, if you go to our docs website, which is docs.saltstack.com, you can find a list of more information on everything we've talked about, as well as lists of built-in modules, built-in states, built-in runners and returners and things like that. So yeah. Okay, any more questions about returners? Isn't this? Is that right? Yeah, okay. So one of the last things that I want to talk about here are custom modules and runners. And normally these aren't usually, sometimes they're grouped together and sometimes they're not. Custom modules are, things that aren't built in, that are specific, that don't come with Salt specifically that you want to use and you want to build out for your specific infrastructure. You can, build your own execution module, and then you can utilize all the powers of Salt and Python, and that would execute on the minion. So when we're talking about execution modules, those execute on the minion typically, whereas runners are an execution module for the master. And you execute them using salt-run. And then this is an example of the jobs runner, which is a really useful runner where you can use different functions to get information about different jobs. So what are the active jobs that are still running? And it'll list those out. There's a bunch of other ones I can't remember off the top of my head, but it's a really powerful way that you can do all kinds of different custom things. You can use databases and web apps and web services. Let's see here. Again, we have a lot of built-in ones, around 25 runners that come with Salt, such as there's a cloud runner. So if you didn't want to use Salt Cloud, you could use the cloud runner. There's a pillar runner, a file server runner. These are just examples of all the different things that are available. And they can connect to external systems, update web pages. They can do a lot of different things, and that's the one that Colton's talking about back there. So if you want to learn more about how to build custom, I think you're talking both about execution modules and runners in your talk. So yeah, it's the last talk of the day and one tomorrow, right? Yeah, so I would definitely recommend going to that one if this is something that would be useful for your setup. Do we have any questions about what we've done so far? Okay.
And then that's pretty much it for the day. We have a question back there. It's there. I've rebooted a minion and have the grain data be there, so it stores it in the grain file. So thank you for coming. Just a personal plug, during lunch today and the party tonight, we will have a booth staffed where you can actually see the GUI. If you didn't see that last night, I know we talked to a lot of people, but we'll be demoing this GUI, the enterprise version that Mark Chen talked about in the opening keynote. So thanks for coming, and find us where most of us are wearing white shirts today. So if you have questions, please grab a SALT employee, and we'd be glad to talk to you and point you to the proper location if we don't know the answer. So thank you.